Okay, so thank you for coming. This is going to be a very practical talk. I don't like kind of quote-unquote bullshit talk, so it's all going to be like examples and all practical and hopefully something that you can apply when you go back to work on Monday, if you know what I mean. And yeah, so let's get started. I'm the director of 7A Security. There's some public reports. I wrote a practical web defense course for e-learn security some time ago about hacking and then fixing web applications. I'm the OWASP, one of the OWASP WTF project leaders, one of the OWASP flagship projects. There's some presentations. I was a developer first, then I switched to security. So yeah, I have a bit of background on both. And if you're interested in this talk, you might like to check some of the public pentest reports where there's like a lot of mobile app vulnerabilities as well. So these are just some of the direct links, but you just go to the website and it's all there. So this is going to be a very practical walkthrough, and we're going to play a game if you want. So this is kind of the types of attacks we're going to see. This is the game. So I'm going to, like in the middle of the presentation, I'm going to ask what is the vulnerability or what is this attack. If somebody gets it right, then I'm going to give you an invite. People were very nice to me here in Austin, so I want to do something nice for you. So I'll give you like a free pass for the course, and of course, because some of my students here from the two-day course that I gave on Tuesday and Wednesday this week, if you get the question right, then I'll give you the pass for the third day that you didn't get, okay? So I give like a small incentive for everybody to participate. So let's get started. So some denial of service, just to warm up a bit. So this was a tracking library. Anybody knows what this command does? No?
Listener.
A listener, yes. And what does it do?
Yes.
Well, yes. And?
Is this something to do with the Android?
Yeah, well, it's to do the, but yeah, you were close enough. So if you want a pass for the for the mobile course, you can give your card, and then at the end I'll tell you what to do. So you can come and take it if you want. And okay, so yeah, you're right. So basically, this is a listener, and what it does is, if the connection is closed within 0 seconds, so immediately it's going to start the listener again. Encryption is off. It's listening on port 80 without resolving DNS, and it's executing the yes command. So what we want to do here is to crash the service. So we're doing a selective man in the middle. So we're doing DNS spoofing with the tracking service that the app is using, and we are trying to crash it. So the yes command is going to like create a lot of stuff. It's basically just saying yes, yes, yes all the time. So this is the memory allocation bug, right? So this is how, thank you. This is how it looks on the simulator. So this would be like the normal memory usage, and this is like after the crash, and this is the crash itself that the project was killed. So consider using another library. I'm going to skip over a little bit of the fixes, but I want the slides to be useful, like if somebody reads them without watching the talk. So yeah, this will be like some of the mitigation. So now let's move on to the SD card, right? So in Android, the SD card is a little bit of the Wild West. So any app can read and write there. You can punch somebody in the face and take the SD card out and read like everything that is there, because there's no encryption. You don't need to know the unlock pattern of the phone. So anytime anything sensitive is saved into the SD card, that could be a problem, right? So, so yeah, saving sensitive stuff in the SD card. So this was a whistleblower application. So like somebody would like report some human right violation to a website, and they were storing the human right violation in XML format in the SD card. So this was really bad because this was like from one of these like oppressive kind of governments, and if like police would stop somebody having this in the SD card, they could like get killed or go to prison or something bad like this, right? So this was quite bad. So now another scenario: text files loaded from the SD card. And anybody sees the vulnerability here? Text files loaded from the SD card. The text file content is embedded into HTML later, and this is the code. What's the problem?
Concatenate an unvalidated variable?
You already got the pass, leave the others.
Including code or script intended to going to load off the SD card.
Yeah, it's cross-site scripting.
SD card, leaving it laying around, they put it in the phone.
Yeah, that could be, okay. Okay, yeah, that would be a valid answer. So if you want, I can give you a pass as well. So come and take it. So yeah, that would be one scenario. Another would be a malicious app right into the SD card and then getting execution on the with privileges of the other application, right? So the text file is loaded from the SD card, then this is saved into a variable, and then this is concatenated into HTML, so you get XSS. And then what this means is a malicious application could write into the text file and run JavaScript, right? So once you can run JavaScript, I really like this website from my friend Gareth Hayes, XSS Kung Fu Master. So if you go to this website, you have like all these handy things to like do partial encoding of things. So just so that it's readable on the slides, this is what the payload was. So you could like read like any database from the storage of the app, and then you can like get access, and you could like forward this to an attacker, right? And this, you needed to encode this so that there's like no single or double quotes or anything inside of the script itself, so that the application would not break and you could still get the payload to execute. So you get like string from char code and then all the characters there. But this would be like the readable format. So this would confirm with the alert that we get access to the SQLite database. And this would be the fix. I'm going to skip over a bit because we have like a lot of stuff to go. So now, sexy copy-paste attacks. So the background here is a crypto vault. So anybody knows what this attack is? Nobody? Okay. So with CSS, you can say like, this text that I'm showing here, this you cannot copy it, right? And this other text that is like hidden, right? You're putting it like below, you can copy it, but you cannot see it because the other text is on top, right? So with CSS, you can do like this kind of messy stuff. So the way it would look on the phone is just select all this text and copy paste it, so you would copy it, and then when you paste it, it's completely something else. Now in mobile applications, because there's like small space on the screen, when you paste it, you could get it like to like show something like looks like non-malicious, but in reality, like you're doing something else. And then with this, we would be able to overwrite like arbitrary files on the application. So this was on the export log functionality, so it would say log exported successfully, and then it would like break the app because we are overwriting the database of the application, and then in the entire vault containing like all the keys was like killed, right? It was like the database was corrupted. So this is like one of the public reports if you want to read more about it. This would be the mitigation. I'm going to skip over because there's a lot. Now spoofing. So one thing that you can do is to show one URL, but then when the user clicks on it, they're actually going somewhere else. So one way to achieve this is with left to right and right to right characters. So this was the example from the pen test. So you send a link like this with these characters here, and then the victim sees this URL, but they actually go to this other URL, right? So this can be useful when you're testing like email applications or chat applications, things like this. Now, content providers, background browser application with a custom URL handler. So this would be the URI of the content provider, right? And then we'll parse it, and then this you add like the fake news, like president disappears after entering police, whatever, and then you just like call the content provider and do an insert, and you would be able to insert like fake news. This was like a news application, so there was like a content provider that didn't have like any checks, any permissions, and you were able to do this. So this is another type of funny kind of attack, right? So yeah, do not export content providers unless needed. If you must export it, at least protect it with a permission that requires a signature of the same developer, right? So this will be the mitigation. Now, local server attacks, right? Like when you're testing a mobile app, like who thinks about a local server, right? Like you're looking at the manifest, you're looking at the info plist on iOS, but who looks at the local server attack? A local server for attacks. And I'm putting here a squirrel because I saw a lot here, so I found that interesting. So this was a Cordova application. It used a plugin that to get around some limitations, it was running a local server. So you could and the local server had a path traversal. So you could get the Etsy password like this. So this was like an HTML file, right? And in here we have two iframes. One is like getting the Etsy password, and the other is getting the files from the app itself, like doing // here. So this is how it was looking like on the phone itself when we were checking this, right? So it's another kind of interesting flaw. And then, of course, an app in the background could do the equivalent of this kind of shell command, which would be like for each of the files that I want to get, just do a loop and do a wget of that and just dump it, and then you would get like all the files dumped like that. So this will be the mitigation. Do not run a local server on your phone and all these kind of things. So now let's check URI schemes. So anybody sees what the problem is? So this is a browser. It was the Onion browser, so it's a browser to use Tor. And then you navigate to a website, right? And while you're navigating the website, this code runs, right? So does anybody see any problem here? Nobody? Okay. Well, don't worry, there's a lot more questions, so you'll get something right later. So the problem is checking that if there's like a force quit, right? So it had like this custom URL, Onion browser. So you could, for example, have an image in your page and just close the browser. So somebody visits your page and the browser closes, and you're like, what? So it was funny. Like you could, and this is just one of the examples. You could also call other functions through the URL. So if you have like a custom URL handler, this is some of the possible attacks, right? Like a website that you're visiting could call things in the app, right? So yeah, this will be the mitigation. I'm going to skip over a bit because we are a bit behind. So now logic bugs, right? These are usually hard to find. Automated tools really don't do a good job with this. And yeah, they're often subtle issues, right? So let's look at this example. JavaScript is disabled by default, right? That's how the application was supposed to work. So this would be like the settings of the application. And this is the code. Does anybody see a problem with this? Just one line of code? Come on.
Yeah, you're enabling JavaScript to run in a web view.
Yeah, but where's the problem in the code?
It's showing that it's disabled entirely. So it's faking the GUI and saying that it's disabled.
Yeah.
Boolean while disabling entirely
Yeah.
for the user.
Yeah, that would be.
But behind the scenes, it's actually enabled.
Yeah, that would be a valid answer. So you get a pass to the to the course. But basically, what happened was the setting itself was not set. So this is saying if you cannot get the setting, just default it to true, right? So that is the problem. So it's getting the preference, and if the preference is not set, it's setting it to true. So this is the proof of concept just to demonstrate that you could run like a lot of JavaScript, and here like you could get like all this stuff, right? So it wasn't working. Now a fix for this would be to ensure the preference is already set in the preference file, and then instead of default to true, default to false, right? So now URL validation, very common problem in mobile apps. So yeah, so what this is doing is if, this is just one, yeah. So what this is doing is if it finds the .onion somewhere on the URL, right, then it's going to ignore SSL warnings. So what can we do with this, right? Because it is not checking that the end of the URL is .onion, right? It's checking just like anywhere in the location. We can register like a subdomain, as we did in the test, right? You can do paypal.com.onion, that's something else. Point it to Google, so it's a completely invalid certificate. So you open this on a normal browser, it's going to show you security warnings. But on the Onion browser, there were no warnings at all because it had .onion somewhere in the host. So it's not in the URL, sorry, it's on the host, right? It had to be on the host part. So the host contains .onion, so no warnings. And you could like man in the middle that like without any SSL warnings, right? So this was the problem, and this is the public report. So yeah, this will be the fix. Now let's look at man-in-the-middle attacks. So secure messenger app. This was the attack. So we were trying to do like XMPP man-in-the-middle. This is a protocol for kind of Java chat kind of applications, right? So what we tried is we are going to disable all the authentication mechanisms and leave only plain, right? So that only the plain text is the only authentication option with this XMPP server that we're trying to use to man in the middle, right? And then this made the application try to log in because it was the only option. And instead of showing an error to the user, which would be like the correct way to proceed, it sent the credentials in clear text, which were these credentials, right? So yeah, this will be the fix, but it was an interesting, so always these fallbacks, right? Like, does the server support SSL? No, then we fall back to clear text, right? So this is one of the attack patterns that we found. So another thing is update checks. So does anybody see the problem with this? It's very easy.
No, JSON just is returning the text, not the web server.
Yes, but what is the problem?
It's not HTTPS.
Exactly. I think she was first. So you get a.
Is x.x really valid? X is a .x file.
Sorry, say again.
X.x.
Yeah, it's just kind of it's kind of censored from the original path. So this was the response, right? So we can change. It's HTTP, so we can man in the middle, like anybody can man in the middle this, and we can change the response from not found to this is version 2 of the application. It's a forced update, and the URL to get this update is this telephone number, right? So the user would get this dialog, and then when they hit update, it would ring like a potential premium number, right? So this is an attack vector against mobile apps, right? That can be useful. So this with the mitigation, of course, validate the URL is a URL and not a phone number and all these things, right? Now another scenario was third-party zip file retrieval. So does anybody see a problem with this? This is the iOS configuration. info plist of the iOS app.
Downloads keys over HTTP?
Say again?
Downloads keys over HTTP?
You are thinking in the right direction, but it's not exactly that.
Is it that key tag that allows insecure loads?
Yeah, it allows insecure loads, but what does it mean to allow insecure loads? Yeah, that's it. You were there. So you get a free pass. So yeah, so that's the problem. This is the app transport security. Since iOS 9, clear text HTTP connections are disabled by default, but developers can override this in the info plist configuration. You can set exception domain. So in this case, this domain is set to allow clear text HTTP, right? So what can we do with this? We can change, because this is clear text HTTP, we can provide any zip file we want. And of course, we can get the app to unzip this file, so we can override any any kind of local files that the app has, right? With this vulnerability. So this will be the way to fix it: set no exceptions and use dependencies that use secure TLS communications. So now let's look at another one. This is a multi-part question, so just pay attention. We have an application. When there's a certificate exception, it will prompt the user. This is the prompt. Accept unknown certificate. You can say always, once, or abort. Then, to process the answer, the application registers a broadcast receiver. Right? Then starts the activity. Well, this will be the activity that opens this dialog. Then it waits, and eventually, when it gets the answer, it unregisters the receiver, right? And this is how it processes the input from the broadcast receiver. It gets the decision, it gets the choice, if it's always, if it's only this time, and then it stores the certificate. So, what's the problem with that? Anybody? Back? Here?
It's not validating you setting the decision ID, the decision choice. It's making a choice for you.
Yeah, but
It's always allowed.
It's always, it changes whenever you put in. It'll always allow it. Even if you say ignore, it says change it to always allow.
no.
It never resets it after it's been set previously.
So, can you speak a little bit louder?
It never resets it after it's been set previously. It doesn't reinitialize the variable.
Yes, but that is not the problem itself. The problem is more about bypassing this prompt without user interaction. So does anybody see, without user interaction, how can we get this to say always or something? The problem, well, I don't know how many hints I can give you, but there's going to be more questions, so don't. Anybody else has, or if you want to keep trying? You are close, but
Is the once choice like a forever choice instead of always?
it is a forever choice, so it stores the certificate, yes, but what is the problem? Because if the user says always, it's the user saying always, so that's the user's choice, so that's not a problem, right?
If it times out, I mean,
No.
So when you say it's once, does it still store that?
No.
the receiver doesn't have permission, so you could watch a show and just
That's it. That's it.
start the activity from
You get the third day, man. That's it. So it's implementing this functionality with a broadcast receiver, so any app can call this. That's the problem, right? I mean, if it was a local receiver, then only the app itself would be able to call it, right? But the problem here is the receiver is something that any app can call. So you can send an ADB shell and pass the decision, right? And set the choice to accept this certificate always, and an app can do this in the background and get to bypass this SSL prompt, right? So that's the problem. Okay, so let's move on. Man in the middle of XMPP. So to bypass, to do XMPP SSL man in the middle without warnings, useful for this is using Prosody, which is a tool where you can implement like your own XMPP server. So you can like DNS spoof like the domain. So for example, chatfacebook.com and point it to an IPU control. And then we got, just doing this, we got the application to accept the default self-signed Prosody certificate by default. So it's just funny, but yeah. So if you need to man in the middle XMPP, Prosody can be useful, and yeah, we got that. So now let's look at another clear text HTTP example. So does anybody see a problem with this? Anybody that doesn't already have a card?
No file permissions were set on the new file?
It's HTTP, okay, that's part of the problem. But what can you do with that?
Override a file?
Who said that? Say that again a little bit.
Override files.
Yeah, that is correct. That is correct. So you get a pass. So yeah, you could override arbitrary files, but in this case, you could even go a step further. So you can change the XML, set a file name that does like a path traversal where you override the preferences file, and then you could set like the download URL of this preference file to be an XML that the attacker controls, right? And then this forced file would be a file where the server URL would be like an attacker-controlled server URL. So this was an application to, like a kind of whistleblower application. So this would mean like all the like human right violations and stuff would go to the attacker, right? So if like a malicious or kind of oppressive government was like doing this attack, they would get the submissions instead of the human right activists, right? So this was a really bad attack because it could, among other things, get people killed, right, in those countries. So in Logcat, right, you would say like, hey, this file has been deleted first, and then it was saying started downloading into the SD card, and then copied over from the SD card, and the traversal goes into the app internal storage and overwrites the preferences file. So this was the attack. This will be the mitigation. Yeah, kind of super short on time. So, anybody sees a problem with this? So the application gets a CSS file from the server, and then it does this with the CSS. Nobody? Okay. So, of course, the problem is it's using cleartext HTTP again. So we can change the CSS file to close the style tag. So because this is like a string concatenation, right? It's getting the server provided CSS and concatenating to the HTML. So it's closing the style tag, and then you can do like script and load your JavaScript, and it's going to load this JavaScript forever because this CSS file was cached on the application itself. So then the XSS is going to run every time the user reads an article. So the next question is, what can you do with this? Because developers always want you to demonstrate, right? So this is what you could do with it. So you could like do an XML HTTP request. You can get like the cookies, the location, the title, the HTML of what the user is reading. So you would see like all the as the user is reading the news, because this was a news reader, you could see like the IP of the user, which user agent, the cookies, the URL they are visiting, the HTML of the news they were reading. But of course, we can go a little bit further than that, right? So with this, we could also, when the user favorited the article, it would be saved as a local file, right? So we have a check here, like if the protocol is not filed, then don't try to read local files, but if not, try to read the files, right? So there was a list of sensitive files, and we would loop through this and try to get the sensitive files from the phone. So with this, I think I have a screenshot. Yeah, we could get like the call history of the phone and stuff like this, right? With these accesses. So this was a very cool attack, you know, to get the the call history from the phone. Yeah, and another thing that you could do is get the local files from the app itself. Because in iOS you have this token, we could get the token from the location itself, actually. So it was like we did like path replace, and with this we can get the token. So yeah, and once you got the token, then you can get like all the local files, because you know like the full path to get the files, right? So this will be the fix. Now let's look at data exfiltration with browsing functionality. So we have an exported activity, right? The app expects other apps to send URLs to it. It opens those URLs and shows them to the user. So this is the exported activity. This is the intent extra processing. So it's getting this search query, intent extra, it saves it into a URL, and then it tries to handle it. So does anybody see a problem with this? We have an exported activity. We have an intent extra query, and this is the URL validation. Does anybody see a problem with this URL validation? It's a regular expression. Come on. Seriously? Nobody? No? So of course the problem is it's accepting file URLs. So it's opening the URL that you pass to it. So what can a malicious app do with this, right? So you can write to the SD card your own HTML file as a malicious application. Then you can send a file URL to this file that you wrote on the SD card, because the SD card is the Wild West in Android, right? So the browser app goes to this HTML file that we are sending as a query URL, and then with this we can like get like file access to the files from the app itself, right? So we can get this data storage from the application that normally would be protected by Android itself, right? So we can bypass this restriction in the permission model in Android. So yeah, with this we could confirm like, with an alert like we are able to read these files from data from the app. So this was quite bad. This would be the mitigation, disable file access, and all these things. Yeah, and this, yeah. So, but now a chat application. So I'm just skipping over because I'm running out of time. I have so many slides. So permanent accesses with data exfiltration. So we had a chat application in iOS where it was output encoding correctly the messages that were coming from one user to another, but it was not escaping the messages that you put in the chat yourself, right? So a way around this would be like to try to fool the user that is receiving the message to paste a message into the chat. So you can say, can you copy paste this message into the chat? It seems like something's not working for me, thank you. And then script whatever. And then if the user copied this and pasted it into the chat, then you will get the XSS, right? So it was a little bit interesting as well. So with this, we could, of course, again, like read like files from the phone, and we can like confirm like access to these files with alerts. Like we are able to read these files like the Safari history and other stuff, right? So yeah, this will be the fix. To sanitize input from all sources, not only what is coming from outside, but what is coming from inside, like the same user trying to access himself is also like a potential vector with copy-paste and stuff. Now let's look at crypto, right? We got a crypto messenger. Does anybody see a problem with this? The app receives encrypted files. And this is how an encrypted file is processed. Nobody? Okay, there's going to be still more. There's going to be still more questions. So the problem is, it's using the original file name, so the file name that the user used to encrypt the file, as the target file, right? So with this, what can we do? Of course, we have a path traversal because we control the file name, so we can do the // sequence, and we can override like any file we want as the user is decrypting this, right? Now, another one, this is very cool, okay? Does anybody see the problem with this? This is a very cool attack, one of the finest in this presentation, in my opinion, biased opinion. Does anybody see the problem here? So we have a PGP email application, and it's implementing PGP in JavaScript, right? So you send an email that is PGP encrypted to somebody else, and this would handle like the decryption of this message.
Is keeping JavaScript where it's displaying that in HTML?
Yes. So that is moving in the right direction. So I'll give you a pass for that. So yeah, the problem is it is concatenating the HTML message into the message variable. So we get XSS on the HTML of the email. So we can close the quote and put anything we want here, like send to the attacker the passphrase and close the quote. So we can steal the passphrase, and we could also like steal the private key of the user, right? Because these are available as JavaScript variables. So we have private key, we have passphrase. So this is just an example to send the passphrase, but we could also get the private key. So you could steal both with just sending an email to a target user, and you get the private key and the passphrase. So that's really cool. Very scary, but very cool at the same time. You know what I mean? So yeah, you could set up a listener, and you would get like the passphrase like this. Yeah, and one way to fix this would be to base64 user input before concatenating it into JavaScript, and of course encode user input properly in JavaScript. So now let's talk a bit about some application that is very close to my heart, Smart Seriff. We had a lot of fun with this one. So it was mandated in South Korea. The first time we tested it, it wasn't using SSL at all. So you have clear text HTTP. Then the second time we tested it, it started using HTTPS, right? So what is the problem here? Now, this one, the people who took my course, they know it, so you are kind of excluded for this. But anybody from the rest sees a problem with this? You only have to read. So, who was that, sorry? Ignore the error, okay. So it ignores with what kind of error? SSL, okay. So you get a pass. So this was the problem, right? So we have on received SSL error proceed, and if the hostname verifier is wrong, it's going to return true as well. So that's all the code. So whatever happens is going to return true. So it's always valid, right? So we get man in the middle, SSL man in the middle without warnings. But there's more. So now this is still Smart Seriff. We have a function that is encrypt decrypt. This is the code. We have as input this, and this is the output. And if we put this as input, we get this as output. Now, does this ring any bells to anybody? Does anybody know what the problem is here? What crypto algorithm can be used to encrypt and decrypt? Yes, but what is the problem? Symmetrical crypto, yes, but the problem is? I heard rumors, but I don't know. Anybody? Is doing an XOR, yes. With? yeah, well, it's, yeah, okay, I'm going to give that, did I give you a card? Or?
Here, give me that.
Who was that? So that's for you. Okay, so it's a hard-coded key here, right? So you can get the hard-coded key from the phone, and of course anybody with access to the app can get the key, so you can encrypt and decrypt as the app does, so this offers like no protection at all, right? So we have a hard-coded XOR key. So I'm going to skip over now the remaining questions because otherwise we're not going to make it. So this was the XOR proof of concept script. So you could, like in Python, we wrote this script for this, and this was the hard-coded key. It had null characters, maybe so that when you use like strings against the app, you wouldn't get the key as easily because the nulls are going to break out the strings in C, right? So you got the hard-coded key, XOR with the ciphertext, and you get the plain text, right? Or the other way around. Now, this was the version 2 of their solution, right? So now we get, well, I'm just going to skip to the solution. So there's the string, and it's getting a fixed string from the app itself, right? So it's getting, in this case, they're using AES, so AES is good. There's nothing wrong against AES for now, but it's a hard-coded key again. So we have like the ciphertext is doing AES of this, right? And you can use it like to encrypt or decrypt because it's symmetric encryption. And this was the hard-coded key. So we have a useless AES with static layers. So putting together all these vulnerabilities in Smart Seriff, we have first a hard-coded XOR key. So we have the phone number becomes this thing, but it's hard-coded in the phone, so anybody can reverse that. It offers no protection at all. Then we have an AES layer on top of this, with another hard-coded key, so also no protection at all. With this, it's sending the request, but it's ignoring the SSL errors that we saw, right? So it's fail SSL. It's as if there was no SSL at all because anybody can man in the middle of that, and with that, you get the response. So it was like the catastrophe summary of this application, right? We find it like so funny, like having like all this useless crypto and stuff. So yeah, this would be usually that, and I just really want to cover this, so let me try. So this was a CRM application with Google Authentication. So this we have an activity that is exported. We have this activity called login web view is saving the Google Authentication token, right? So and this is the code where it finished. So of course we have here SQL injection, right? And what we could do is to simulate an attack from a malicious app first, right? So attack variant 1, malicious app attack, is we go to the data storage of another app. We save this like test.so file, and we set it to permissions for everybody so that other apps can read this file, right? So with this, we are proving that the app can read from this storage because anybody is able to read with these permissions. And we are sending an intent calling this activity, calling the URL handler with a token that is not really a token, but is like exploiting the SQL injection. So this will make more sense here, where it's decoded. So in Logcat, we can see SQL cipher database, SQLite encryption, DL open failed, has bad elf magic, right? So this means that it's trying to run it, right? So it's not just SQL injection, which you can see here, the SQL injection itself, but it's also code execution because it's trying to run the binary that we control, right? So it's like super cool attack, one of the finest in this presentation, in my biased opinion. So. And then attack variant 2, very cool, because the activity was a browsable activity. This means the activity can also be called from a website. So if the user is visiting an attacker-controlled website, we could first force the download of a fake test.so binary, and then call this binary, right? So what the fake page is doing is encoding the, well, this is the payload, right? And then it calls first with an iframe this previous page, right? That is doing the download in the background. So we have an iframe downloading the test SO file, the binary, and then we are setting the iframe source of the trigger iframe, which is, you can see there's no source here. We are setting it with JavaScript 5 seconds later, so there's like enough time to download the binary. And then this will trigger the code execution again, right? So it was very cool to do it in both ways, right? So with this, let's try API attacks really quick. So retrieving files from the server, very typical example, right? Because of course it's mobile, but mobile applications also have APIs, so it would be incomplete, this presentation, without some kind of server fun. So this is retrieving a file from the server. This is the code. I'm going to skip for the solution because we're short on time. So this is doing a string replace, classic filter, right? In anybody's mind, like this makes sense to replace dot dot slash with nothing. But what happens is you can't do this, right? So when you replace dot 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 slash slash, right? If somebody gives you this and you replace this, set it to nothing, then you get this, right? So you can supply this and still get the path traversal. So this kind of filter is wrong, right? It doesn't work. Like you can get around it. So ways to fix this: use the get the base name of the path, get the real path, check if the path is where you're supposed to get it, and reject dot dot sequences. Some mitigation. Now uploading files to the server. Skipping to the solution again. User files, right? We get a parameter from the user, PHP fingerprint, run command. Then this is doing a join, so it's concatenating the strings. So a Python list is concatenated into a single string, and then it's running this through suppresses popen with shell equal true. So this means we can run like any command on the server. Now again, hack vector, super useful tool. Only using your browser, you can like encode and decode like a lot of using a lot of algorithms. It's I recommend it. It's super handy. And this also makes the slides a little bit more readable. So we get URL encode of this. This was the payload. So we are doing a pipe, wget who am I, and you can basically run any commands you want. So this would be the payload. So we set up a listener. We set up a reversal one-liner. You can Google these reversal one-liners, and there's like a few ways to do this. And then you just send the payload, and we, of course, got the shell back, so it was really cool. Yeah, so this will be the fix. Avoid these string concatenations, escape user input, and all this. Now API leaks. So from Smart Seriff, we had the bully, what we affectionately called the bully API. So imagine there's a really bad kid in the class. He wants to mess with other children. This was an app mandated in the entire country of South Korea. So any parent and child was forced to install this app. And then, of course, a bully likes to mess with other children in the class, right? So just knowing the phone number of another child from the class, it would ask the API of Smart Seriff, hey, I want to mess with this kid. I said, Smart Seriff will tell you like this API, right? It will say, okay, sure, this is the parent phone number. So with that, you can already do some damage. But as the bully guy, you really want more because the login page requires the parent phone number, but also the PIN, right? So you can ask nicely Smart Seriff, like, come on, give me the PIN as well so that I can really mess with this kid. And of course, it gave you the password as well with the XOR that we saw before. So this is how it looked using curl. So you could get the parent phone number and the PIN, so you could log in as anybody's parent, and with that you could control, like, can this child use this phone? Never. Can this child use these apps? No, they cannot run any apps. Can this child visit these URLs? No, they cannot visit any URLs. So you could like do all this kind of messing with other children. And because it was forced in the entire country, we could try like phone numbers at random, and we could get like the password, the phone number, and the password for a lot of parents in South Korea. Yeah, super easy because like there were so many users, right? And then, yeah, I'm kind of short on time. So and then we have Smart Dream. So I'm just going to explain it with the demo, and then we'll be done with the presentation. So Smart Dream Smart Dream was an app that would like record. It would alert the parent. It's similar to Smart Seriff. It will be similar to Smart Seriff, right? But what it's doing is it's finding if the child is using harmful words, right? So for example, if the child was using like menstruation or sex or something like this, right? Then it would alert the parent. And then in the API, all these messages would be stored, right? These are like random Korean characters. It's not what the children really wrote, but this is how it would look like. For each phone number, you could get like all the messages that the child sent. So we could like download the entire database of messages that were recorded from these children, right? Which is really bad. So this is just another example of API leakage, and with that, I'm done with the presentation. So I'm not sure if we have time for questions or not, probably not, but that's the end. Thank you very much.